right, guys, up or the second part here of chapter 9. We're going to look at confidence intervals for what are called proportions, and then just briefly how we determine the sample size that we need when we're conducting our research. I'm not sure why, but for some reason my pen annotations don't seem to be saving, which is weird because I've done this many times before and they have saved. So I'm going to try to figure out how to fix this, but for now I'm just going to get this video up. So here we go. This is the third learning objective from chapter 9, talking about the idea of proportions, which is a ratio or a fraction or a percent that indicates the part of a sample or the part of a population that has a particular characteristic. And so an example down here, Southern Tech Career Services reports that 80% of its graduates enter the job market in a position related to the field of study. So that is a proportion of the population, right? So 80% of the whole population has a job, okay? For a sample proportion, this is the formula that we would use to calculate the sample proportion, where X is the number of successes, and I'll explain this more in a second, divided by N, the total number of observations in the sample. If we have a population proportion, we actually use this pi symbol to identify it. And so, again, this represents the percent of successes in the entire population. Just a couple of things here. This kind of goes back to the binomial topic that we skipped in chapter 6. But the value of the sample size n times the proportion of the population pi and n times 1 minus pi should both be greater than 5. And this is just so that we can use the central limit theorem and use the standard normal distribution with our z charts, okay? So really more technical than y'all need to know. You just need to know for this, we're going to be using our z-scores again, okay? And so here's your formula down here for calculating a confidence interval for a population proportion. So you can see this lowercase p, again, is if we go back a slide, it's, okay, it doesn't want to let me go back, but it's the sample proportion, right? The X over N, okay? So we calculate that first. We'll find our Z based on whatever confidence interval we're looking for, 95%, 99%. And then we have the square root then of that sample proportion times 1 minus that value, and then divided by N, our sample size. But let's plug in some numbers and hopefully make this a little bit more concrete. So here's our first example. Let's just calculate that very basic sample proportion. So we've got a random sample of 100 voters in a district, and 60 have indicated they would vote for some particular candidate. So what is the sample proportion, P? Again, we find P by the number of successes, that's X, divided by N, the sample size. And so we had 60 voters indicate they would vote yes. So we have 60 then divided by the full sample size of 100, or our sample proportion here is 0.6. What is the population proportion for this example? It's unknown. And so that's the case where we're going to use the sample proportion as an estimate of pi, which is what we've been doing, right, this entire chapter. When we don't know something about the population, we use our sample as an estimate instead. So let's go through now and use that second formula to actually calculate the confidence interval for the population. So here's our problem. We've got these bottle blowers of America. They are considering this proposal to merge with another group, and they need 3/4 or 75% of their membership to approve this merger. And so they take a random sample of 2,000 members, and it reveals that 1,600 plan to vote for the new merger. So what is the estimate of the population proportion? And can you conclude that the necessary proportion of members favors the merger? So again, we're going to use that sample proportion to estimate the population. So we take the 1,600 yeses, divide by the sample size of 2,000, and we find that our P is equal to 0.80. Now we're going to use a 95% confidence level, and we're going to use that formula that we just looked at here to determine our interval. Again, our P is 0.8, so we have 0.80 plus or minus the Z value for a 95% confidence level is 1.96. If you don't remember how I got this, you need to go back and watch the first half of my chapter 9 explanations, the first video that I posted a few days ago. All right, and then we'll multiply that times the square root of p times 1 minus p divided by the sample size of 2,000. And so we have 0.8 plus or minus 0.018, where 0.018 is what we call our margin of error. And so calculating this out, the min here is 0.782 and the max is 0.818. So what do we conclude here? If we need 75% of the membership to vote yes in order for the merger to happen, well, we're 95% confident that the true population mean is going to be between 78 and 81%. Since 78, the min value here, is greater than the 75% needed, then yeah, we're really confident that this is going to pass. Okay, so let's work out a second example here for creating a confidence interval for proportions. So we have a candidate, Wilson, considering to run for mayor for this town in Montana. But first, she wants to conduct a survey. She just wants to see what's the feasibility here that she'll actually get voted into the position. So she takes a random sample of 400 voters, and they find that 300 would vote for Wilson to be their next mayor. So first, we're going to estimate the value of the population proportion. Again, we don't know enough about the population, and so we're going to use that best estimate that we have, which is the sample proportion. So using our formula P equals X divided by N, we have P equals 300 divided by 400, or a P of 0.75. So that's our sample proportion. For this one, we're wanting to develop a 99% confidence interval for our population proportion. So we're going to use this formula that we had on looked at previously, formula 9.4 here, and we're going to use our z value for a 99% confidence interval, which is a value of 2.576. So we plug all of that in. Oops, sorry guys, it looks like my lines got messed up a little bit, but you can see here we have 0.75 plus or minus that z of 0.2576 multiplied times the square root of P times 1 minus P over N, where N, our sample size here, is that 400. And so we'd have a margin of error of 0.0558, and our interval would run between 0.694 and 0.806. So should Wilson run for mayor? I say yes. Let's assume that Wilson needs at least 50% of the votes to win the election. Well, then we are 99% certain that the true population proportion mean is somewhere between 69.4% and 80.6%. Since that minimum value of 69% is much greater than 50%, then I am very confident that Wilson would win this election for mayor. Okay, so the last learning objective that I'm going to cover for chapter 9 is determining sample size for means, learning objective 9.4. And so, it does matter how large our sample is. This is a concept that we've kind of talked about before. The larger our sample is, the more representative it is of the population, the closer we get to the true population parameters. But we still want to be reasonable when we're conducting our research. So there's 3 things that we need to think about when we're trying to figure out our sample size. What's the margin of error? Okay, this has been, when we've done our confidence intervals, there was a value, then plus or minus something, and I kept calling that the margin of error. That's what we're talking about. We're going to designate that with a capital E here, okay, margin of error. What's the desired level of confidence for the work that we're doing? Is 95% sufficient, or do we need to be at 99%? Could we go as low as 85%? That matters as well. And then how much variation is in our population? And so using all those 3 things, we come up with this formula here, where again, N is representing our sample size. So N equals, and then we're going to take the Z value for whatever confidence interval we're wanting, times either, if we have it, we'll use the population standard deviation, okay, the sigma. If we don't, then we'll use the sample population standard deviation, the lowercase s. We divide the multiple of those two by our standard, our margin of error E, and then we square that, okay? Your results aren't always going to be a whole number, but for a sample size, we need a whole number, so we're going to round up. If you had 39.5, we would round up to 40. Even if you had 39.1, we would round up to 40. So let's look at a couple of examples here. So we got a student that wants to estimate the mean monthly earnings of city council members. She is comfortable having a margin of error of up to $100 when estimating the population mean. She would prefer to report an interval of 95% confidence. And she found a report by the Department of Labor that reported a standard deviation of $1,000. So what's our required sample size? So here's the formula that we're using. So we take that Z value that corresponds to a 95% confidence level, so 1.96. We multiply that times the population standard deviation of 1,000. We divide by the margin of error that she's okay with, the 100, and then we square our results. And so we would get an answer of 384.16. And so we round up, and we would say that a sample size of 385 individuals is required to meet the specifications of the research that she's doing. Okay, so let me walk through one more example for you with calculating a sample size for population mean. So suppose we want to estimate the population mean within 5, so that's my margin of error, 5, with a 99% confidence level. We find that our population standard deviation is estimated at 15. How large of a sample is required? So again, using the same formula, N equals, well, for a 99% confidence level, our Z is 2.576. We will multiply that times the population standard deviation of 15, and then divide by the allowed margin of error of 5. And I was trying to do the formula in PowerPoint, and I couldn't get my squared to work, so then we take that value and square it. And we would get an N of 59.72. So again, we're going to round up, and we would say a sample size of 60 is required. And guys, I'm going to go ahead and stop here. I know in the slides that I posted in D2L, there were 2 more PowerPoint slides that talked about how to determine the sample size for proportions. But given this transition, I've decided just to go ahead and let's just cut that topic out. Again, send me an email if you guys have any questions about the second half of Chapter 9.